see, this is a pulley whose radius is r and moment of inertia is I, and along its rim there is a cord, there is a string wrapped, and it is hanging with mass m. So when it releases the ball, this mass will come down with the accelerations. Here we have to find its acceleration. So what quantities are given? Mass, radius of pulley, and its moment of inertia. All right. So there is a tension in the string, this tension, and this same tension will act on the block as well, and this is mg downward on the block. So net force on the block will be mg minus t, and that's equal to ma. So have I got one equation regarding the acceleration of the block. Okay. So if this block comes down with acceleration a, every point on the string will have the same acceleration. So this acceleration will be also of this point on the rim of the wheel. This point will have the same acceleration as that of the block, because both are connected. So if this come down, this point will also have the same acceleration. So this pulley will have angular acceleration A equal to A by R, because we know A equal to R alpha. This is linear acceleration, this is angular acceleration. They are related like this. So if there is a point on the rim having acceleration A, so the pulley have angular acceleration related with this equation. Okay, all right. So we have got this equation, and mg minus t equal to ma, this one, and since this pulley have angular acceleration, there must be a torque, net torque on the pulley which is generating this angular acceleration. Okay. So what are the forces on the pulley? The forces is that one, that force which acts on the center, and this force will generate no angular acceleration because its torque will be 0. It is passing through the center, and there is a tension T. This T is at distance r from the center, so it will have a anticlockwise torque. So this force have torque tau equal to, we know, moment arm times force. Moment arm will be this one, this length, r into t, tau equal to rt. Okay, and net torque equal to I alpha, we know that. Okay, so T will be equal to I alpha by r, and we can write alpha as A by r. Put it here, A by r. So I A by r square. So we have got the value of A in terms of acceleration. Now we can put it here in that equation to get the acceleration of this block. Mg minus Ia by r square equal to ma, mg equal to I by r square plus ma. Now acceleration will be mg upon m plus I by r square. Now if the pulley is given as a disc, if this pulley is simply a disc, we can put I equal to half mr square, and r square will cancel out. And if this is like a wheel mr square, this pulley could be also a sphere, this could be also a cylinder. So accordingly its moment of inertia formula will change, and you have to put here. So this is expression for acceleration. This acceleration is being constant. So this block is coming down with constant acceleration, and if we have to find its velocity after 3 seconds, after 4 seconds, 5 seconds, whatsoever it's given, we can use 3 equation of motion as well. We can use u plus at s equal to since u is 0, it start from rest, I can write as at and s equal to half at square. So, how much distance it descended, we can use this. Another thing that you have to keep in mind here is that energy conservation will be also valid. These blocks come down, its gravitational potential energy decreases and it converted into kinetic energy in the block and rotational kinetic energy in the wheel, right. Suppose this block come down h height, it comes down h height and it acquires speed v. So, loss mgs equal to half mv square and half I omega square. So, this is kinetic energy in the block and this is rotational kinetic in the wheel, right. So, this is kinetic energy in block and this rotational kinetic energy in wheel, right, and this is what loss in gravitational potential energy of
the block.
Loss in gravitational potential energy of falling block.